Okay, so we are going to talk about the properties of numbers. We're going to review some of the properties that are on the bottom of your sheet, and we're going to do some additional ones, so you'll want to add those in your notes book and maybe on the back of your learning goals sheet, okay? First property we're going to talk about is the zero property of multiplication, which states any number multiplied by 0 will always be 0. It only works for multiplication. For example, 4 times 0 equals 0. 0 times 567 equals 0. So this is a pretty basic property that you've learned a long time ago. But it's important for you to understand that you don't just multiply by 0 because you can. It's actually a property of number. It's a proven property of number. Okay. The next one, that's one of the more important ones that you need to know and able to do multi-step equations, is the distributive property. Okay? The distributive property means you can break apart numbers in multiplication problems to make the problems easier to solve. You have been doing this since about 2nd or 3rd grade when you did partial sums, partial differences, and partial products. You are essentially using the distributive property. Okay? So one way to look at it with regular numbers is like taking 27 times 4. You can take the 27 and you can distribute it, which means you can take the 20 out and you can do 20 times 4, and you can pull the 4 out, and you can, not the 7 out, and you can do 7 times 4, and you'll get the same answer. On this one, instead of multiplying it by 48, you can take 3 times 40, and you can take 3 times 8, and get the same answer. It's called the distributive property. Okay? It means you're breaking apart one of the factors to make the multiplication problem easier to understand. Okay, so let's look at an example of using the distributive property in a different way. Okay, so we talked about how it relates to partial products, partial sums, by you can taking part of a number and multiply it by the other factor. So let's look at this one. We're going to think about it kind of like trick-or-treating. Okay? When you are trick-or-treating, you're giving out candy. If you have 3 types of candy, you have chocolates, you have bubble gums, you have apples. Trick-or-treaters are very picky. Each set of children have requests on which type of candy they want and how many of each type they want from you. Okay? First group rings your doorbell. There are 2 children. And each one wants 2 chocolates and 3 bubble gums. What you're thinking of when you're thinking about the distributive properties, it means you're taking a quantity and you're distributing it out to other quantities. You're giving it out. You would write this as an algebraic equation as this. You have 2 kids. Okay? Those 2 kids want 2 chocolates and 3 bubble gums in each bag. Right? Yeah? Yes. So you need to take 2 chocolates and 3 bubble gums and put it into a bag how many times? 2 times. Because you're multiplying by 2. So you would have to take 2 chocolates, put them there, 2 chocolates, and put them there, right? So you put 2C in how many times? 2 times. Okay? Then you would have to take the 3 bubble gums, and you would have to go 1, 2, 3. And then you would do 1, whoop, 2, 3, even though the bag disappeared. It's a ghost bag. It's Halloween, yes. All right? So what I did is I took my candy, and I distributed it equally into 2 separate bags. It's called the distributive property. Okay, so if we look at that, this is what we did. We have 2 C's plus 3 B's, which means I have 2C plus 3B plus 2C plus 3B. When I do that, how many C's, how many pieces of chocolate did I give away? 4. I gave 4 chocolates away, And how many bubble gums did I give away? 6. Okay? So when I distributed 2 chocolates and 3 bubble gums to each of those 2 kids, I gave away 4 chocolates and 6 bubble gums. Okay? We have another set of trick-or-treaters coming. Okay? This time 3 kids show up. And each kid says, I want 1 bubble gum and I want 2, what was A? Apples. So you have to distribute 1 bubble gum and 2 apples into how many bags? 3. So bag 1, you do 1 bubble gum, 2 apples. Bag 2, you do 1 bubble gum, 2 apples. 3, you do 1 bubble gum, 2 apples. How many bubble gums have you given away? 3. How many apples? 6. Okay, it's 9 total pieces, but it's not 9 of all the same things. So you can't say I gave away 9 of all of them. You have to say I gave away 3 bubble gums and I gave away 6 apples. Doorbell rings again. This time 2 kids are there. What does each of those kids request? Chocolates. Okay? So, how many apples do I give away to those 2 kids? 6. Apples, not 6. Be very careful that it's not, you didn't give 6, you gave 6 apples. It's really important that you have that, you keep that variable attached because that's showing how many apples you gave away. 6 apples. Yes?
It's like, I watched the video last night on like terms. It's basically this.
On what?
Like terms.
Yes. This is combining like terms, yes. A and A is a like term. Okay? So this one, okay. Okay, so we'd have 6 apples and 5 chocolates given away.
No,
10, sorry, you're right. 10 chocolates. Okay? By looking at this, when we have a quantity in parentheses, and we have to take that quantity, and by quantity means we don't have one thing. We're not giving 3 candies in every bag. If I was giving just 3 candies in every bag, would it be different than this? Yeah, because I would just have to do, if I gave 3 out here, I'd have to do 2 times 3, right?
Yep.
I'd give a total of 6. If I gave 3 at a time, just 3 random in every bag, I would just do 3 times 3, right? On this one, if I did 2 random in every bag, I just do 2 times 2. That's not what's happening. I'm giving 2 of a very specific amount of things, and it's 2 different things. It's 2 candies, or caramel apples, 2 bubble gum. The next time, 1 bubble gum, 2 apples. Okay? So it's being more specific. So one way we can show how we distribute it is by adding the quantity as many times as it says we're distributing it and doing addition problem. Okay? So here we ended up with 3b plus 6a. Here we ended up with 6a plus 10c. Here we ended up with 4c plus 6b. Okay, so that's one way to do the distributive property. Whatever your multiplier is, 4, 5, 6, 10, 12, 1, 9, you take what's in the parentheses and you add it together that many times. That's one way to distribute it. Does anybody see an easier way? Looking up there, do you see another way that you go, why couldn't you just do this? So look for patterns. Look for patterns from the initial problem to our answer, or to our simplified problem. Anybody see a pattern in there? If your hand is up, I want you to find somebody whose hand is not up. I want you to whisper that pattern to them, and then I want you to ask that person, does that make sense? So I want someone who did not have their hand up the first time, and somebody who had their hand up came over and talked to them. Explain what you think they said. What's a different way to do it? Okay, can you explain that a little bit more? Like, give me specific with this one. So you would take this multiplier and you would distribute it to each term within the problem. Yes. So this is considered one term. It's a number and its coefficient. Can I separate 3 and b? No. No, because I'm talking about 3 very specific things. I'm talking about 3 bubblegums. I can't take 3 and bubblegum apart because I'm talking about 3 bubblegums. So if I do 2 times 2c, what do I get? 4c. If I take 2 times 3b, what do I get? 6b. It's still bubblegums. If I have 2 of them, I have 2 bubblegums. If I do 3 sets of those 2, I have 6 bubblegums. The b doesn't change. On this one, what would I do? Grady, explain it to me. Times 1b. Yep. Yep. And that would be it. Yeah. I can't add them together. But what you'll hear is the quintessential, it's the most common algebraic thing. You can't add bananas to apples. Okay, that's what everybody likes to say. And our first algebra teacher would say, you can't add oranges to apples. You have 5 oranges and 7 apples. You can't put them together. They're not the same. So when you're talking about 2 different variables, they are not the same thing. Yes. No. Okay. What would I do here? Once again, check yourself. Are you in a conversation outside of what we're doing right now? Okay. How would I do this one? Patricia. 2 times 3a and 2 times 5c. Okay? We can distribute our multiplier evenly to each of the terms within the parentheses. Okay? So what it would look like algebraically is you have 2 times, and it's called 2 times the quantity 4a plus 3c. Okay? When we say the quantity of, that kind of says we're putting parentheses. So you would do 2 times 4a plus 2 times 3c, which equals 8a plus 6c. This one would be written as 2 times, so it's 2 times the quantity 6x plus 2y. You have 2 times 6x, 2 times 2y, 12x plus 4y. Same there, Paul.
So in all of these, it's basically just you take the number outside of parentheses and you multiply it with all the number in parentheses.
Yes, just like when you did partial products. When you did like 24, you would do 4 times 20, 4 times 4. Yep, it's same, except we're adding variables. So it's the same concept, but we're adding variables. All right, I want you to do these 6.